I'm Sarthak Shilwant, and this is my submission for the fellowship application for the IMDb Movie Review Sentiment Analysis project. This is the NLP task which I'm focusing on. So, before starting with this project demonstration, I would like to show how the dataset has been generated. So, this was the main PDF that I have found, and like it has shown like all the possibilities of how the machine learning was taking place in 2011. So in this, they have shown like how standard methods for creating the word vectors were not suitable for it, and so the capturing of semantic meaning for it, say like the king is very similar to the queen, but they were not capturing the sentiments for it. Like if how wonderful and terrible are represented as adjective, but they don't show like the emotional polarity of it. So with this, the paper has come with a new approach of having the components for it. So they have the semantic similarities. They have done it with the two methods, which are like the one is based on the star, which is the reviews for the movie, and it is done with the supervised semantic approach, and other one is the unsupervised semantic approach, where the model learns itself with the help of various strings of it attached to it. Okay, and that's how this data set was created with more than like 50,000 uh, unique reviews for it, and it has shown like it it is more suitable for uh, the techniques such as bag of words, which were the traditional approach back then in 2011. Okay, then going back to the code. So first of all, we'll import some basic libraries like pandas, numpy, matplotlib, plotting, seaborn, which is an addition to it, and also the regular expression and other libraries such as some popular train test split, then term frequency identification, and other metrics for just the prediction of it. And also, I've imported the TensorFlow libraries, and these are for the neural network. Okay, and then the data set is been loaded from the zip file that I've been downloaded, which is from this link, and I've read it using pandas and read underscore CSV and converted it into the data frame. Okay, and the shape of it is like 50,000, and it has the uh, two separate sentiments which are positive and negative. And here we can see with the DF had the first few rows of it and the sentiments for it. And let's uh, do some of the EDF for it now. And with it, we could see the number of previews, columns, missing values, and other checkpoints. And also the I've visualized it before. And yeah, so these are some of the main charts that I've found when I searched through this IMDb movie review project. So these are the sentiment counts. So it would show like how are the positive and the negative sentiments. So it is equal distribution of it with great data. And also there is a review length analyzer. So it just converts it into string and then gets the length of it, and it would show like how many characters are there and what is the frequency for it. Okay, and now let's go on the text pre-processing. So I've found various notebooks for it, and like what are the main text processing things that could have occurred. So first we are lowering the text, then we are uh, removing all the HTML tags, then we are removing punctuation marks, then extra white space. There were other notebooks also, they were more focused on removing the emojis and other sort of aspects for it. But here I have not found it as much needed for this task as there are no emojis present in it. Okay, and then we have applied the clean review as the dataset. So it has passed the text from all the text that we have, and we have converted it into a clean review dataset, which is just passing the review dataset with the clean text function that we have created here. Okay, and then we'll have the, let's say, example of stripping it to the 100 strings. So the first 100 characters of it, and we'll see the difference between the both of them. Okay, and now let's let's go with the first model, that is the logistic regression with term frequency inverse document frequency. Okay, so the logistic regression is like one of the basic founding blocks in machine learning. So I've tried to inculcate it and start with the model. So first, we need to understand the importance of it and to avoid the overfitting for it. So first, we'll just split the data into X and Y, and this is the normal train test split model that can be found using scikit-learn. And here we have given the test set as 0.2, which is like the 20% of the data set. So we have like 50,000 samples, so 1,000 sample would be used for the testing, and we have initialized the random state at 42. We can have any value for it, and we are just stratifying it. So to have a better output for it. Okay, and you can see the training sample here and testing sample here as 1000. Okay, and now we have using the TF-IDF, that is converting uh, the string into number. So there is TF-IDF vectorization. So basically, it is inverse of uh, term frequency of it, and we have added the fit transform of training and testing to it, and then we have converted into an accuracy matrix for it. So you can see the classification report here and the accuracy for the model, which is done using the logistic regression with iteration of 1000. So the value of it is uh, the value of it grows when we run this when they run this cell, and after a particular point it just stops and it shows us the accuracy for this model. Okay, and there is the precision, recall, f1 square, and other values. Okay, and now let's visually understand this. So this is the confusion matrix, and here are the most important words, and here is the review length by sentiments, that is positive and negative. Okay, now the second model is the LSTM, the long short-term memory model. And for this, it is just some kind of a neural network model that I have learned. So with this, we are passing the maximum words and the maximum length of it, and then we are using the tokenizer to tokenize the number of words, and we are just calling it as the max word currently. Then there is X train sequence, which converts the text into sequence. Then we have padding sequence over here, and then we have just built a normal sequential model out of it. and embedding is having the max words that is like 5,000. Then we have just provided the LSTM with 64 neurons of it and the dropout of zero point 0.4. And we are using the dense for it. Dense is like connecting all the neurons to each other uh, in a fully connected way. And we have provided the sigmoid activation functionality to it. And there is Adam optimizer, and we are also having a loss functionality with binary cross entropy. And then we are giving the matrix for it as the accuracy matrix. Okay. And after the model is trained, we would uh, let me show you. Okay. The model is sequential, and then we have the required output as it. Okay. And then we have performing the model.fit. So the epoch is 3. So uh, I found out that with more epochs, it just get overtrained by it, and it just not show a very good result of after it. And then the validation split as just 20% of it, and the best size of 32 of it has been given. And just plotting it uh, to get a visual representation of it. So with more epochs, the model gets overtrained by it, and the validation accuracy is also decreased. So we have I've tried to keep it like with 3. And here is the model loss. The more the loss, the means the lower the loss, the better the model. Okay. And final, I've just added the comparison between the logistic regression and the LSTM. And I have given some kind of test reviews for it. And here you can find that the model performance for logistic regression is 0.888, which is like 88.8%, and with the LSTM it is 86.2%. And for the samples, you can see like the movie was surfacing. I loved every minute of it. So the logistic regression predicts it positive with confidence of 99%, and the LSTM predicts it positive with confidence of 88%. Here, the other example with worst movie ever and complete waste of time. The logistic regression predicts it negative with 100% confidence, and LSTM predicts it negative with 0.007, which is like converted it to like we can say like 99%. It is predicting it as negative, and when the review is somewhat like a decent, it is predicting it 68% positively, and here it is also somewhat like 100 minus 24, which is like 74, 76%, 75.6% of it as a negative review. And Uh, that's it that I want to show for this, and I would be happy to be part of this fellowship and be able to be part of the amazing mentors that would be available for me for the 12 weeks of it. And that's it from my side. Thank you.